Hello, welcome to 12.3 about polygons. In today's class, as usual, you will need your notes for the video lesson. And then there are two independent practice worksheets. The first one is about identifying quadrilaterals, and the second one is finding the measure of the missing angle. Okay, polygon is a type of 2D shape. The word polygon actually comes from two Greek words, which you can see right here in on the first page. The word poly means many and gon means angle. So it kind of, when you put those two things together, many angles, the word poly means many angles. In the purple box down here, we can see that the basic definition is a polygon. A polygon is a closed 2D shape made of straight lines. So it cannot be a circle, a shape with curves, or anything with an open loop. So in this yellow box right here, you can see examples of polygons. You might recognize some as, shapes that we can identify, such as a triangle or a square. But a polygon doesn't necessarily have to be a recognizable, I don't want to say recognizable, like it doesn't have to be a shape that we can categorize in like the traditional kind of way. So it doesn't have to be like something we can name. It doesn't have to be like the traditional square, the traditional rectangle. There's lots of other different types of names for those polygons. So in the red box, we have not polygons, a circle, a semicircle, a heart, a crescent, or a moon shape. Those are all not polygons. All right, so here are some nameable polygons, or kind of like identifiable, recognizable polygons. So we know triangle, or we should know triangle. A triangle has 3 sides. A square is a polygon with 4 sides. A pentagon is a polygon with 5 sides. Hexagon, polygon with 6 sides. Heptagon, 7 sides. Octagon, 8 sides. A nonagon, 9 sides. Decagon, 10 sides. Hendecagon, 11 sides. And dodecagon, 12 sides. So these are kind of what we would call like regular polygons, but it can be a polygon and still be a hexagon if it doesn't take on this exact shape. So if we look at this shape up here, how many sides does it have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is technically a pentagon because it has 5 sides, but it's not a regular pentagon. And we're going to go over what that means. So the guided notes for 12.3 for this section, it does have quite a few pages. I think it has 4 pages, but there's a lot of definitions and references that I put in there. I tried to make them nice and big and colorful and easy to reference. So a couple seconds ago, I mentioned a regular polygon. What is a regular polygon? Regular polygons are closed, straight-sided figures that have equal sides and angles. In math, we like working with regular polygons because they're regular, they're predictable, they have equal sides, equal angles. Just having those characteristics allow us to kind of deduce or find out certain information based on knowing that, or like having all of those in place. So having equal sides, equal angles. We like that because we're able to do certain things with them, which we'll talk about later and in a different section. Okay, so if you have a polygon, a regular triangle, I'm going to loosely use that term. An equilateral triangle has 3 sides and 3 vertices. So if you remember, vertices are where the 2 sides meet. So it has 2 sides, 3 sides, 3 vertices, those 3. So singular vertex, 2 sides come together to form a vertex, but the plural of vertex is vertices. 3 sides, 3 vertices, and all sides are the same, that's same length, and all the angles are also the same. So the interior angles, these, that makes it an equilateral triangle. It's a regular polygon, it's an equilateral triangle. A square, which is also known as a quadrilateral. We're going to talk about quadrilateral in a few minutes. It has 4 sides, 4 vertices. All the sides are equal. All the angles are right angles. Regular pentagon has 5 equal sides, 5 equal angles. Regular hexagon, that's where kind of we talked about it's a recognizable shape. So whenever we see this, we recognize that as the hexagon. It has 6 sides, all the sides are equal, all 6 interior angles are equal. Then the last one is a regular octagon. It has 8 sides and 8 vertices. All of the sides are equal. All of the interior angles are equal. Okay, so here are some regular polygons in the first column here. Regular polygons with an odd number of sides. So this one obviously has 3. That's an equilateral triangle because all of the triangles are the same. Regular polygon. There are some regular polygons with an even number of sides. Then we have irregular polygons. We're not going to work so much with irregular polygons in this, at least in this section. And I'm not sure about in this chapter. I have to look forward a little bit. So remember, regular polygons have equals, all of the sides are equal length, and all of the interior angles are the same. They're congruent. Irregular polygons do not have sides that are the same length, and the angles will be different. If you have, let's say you have a hexagon, and it has 5 out of the 6 are the same length, and the 6th one is not the same length, it's still not a regular polygon. It has to be exactly equal. Irregular polygons. So actually, a classical rectangle or classic rectangle is not a regular polygon because all of the sides are going to be different, right? So you're going to have 2 sides that are the same length, and then the other 2 sides are going to be a different length. Okay, so basically just being able to identify a regular polygon versus an irregular polygon is important. That brings us to our first example. Name each polygon and indicate whether it is regular. So A, B, C, or sorry, the shape for A. We see the vertices are labeled A, B, C, D. And we can tell right away, and if you want to pause and kind of figure out the answer and come back, you can. A, B, C, D, we would consider that a quadrilateral because it's a 4-sided polygon. However, it's not regular because the sides are not the same length and the angles are definitely not the same length. So it has to be both. It has to have same, the interior angles have to be same and the sides have to be the same length. So this one is a quadrilateral, and it's not regular. It's not a regular quadrilateral. For B, there's some kind of hints on here. So we can obviously count the sides. There's 6 sides. So we know that this is going to be a hexagon, right? Obviously we're not gonna like take out our ruler and measure. And even if we wanted to, we don't need to, because when we have these like this, so each side has 1 line, that's telling us that each of those sides are the same. If we had, for example, we're looking at A, we would have to mark these like this. That's telling us that each side is a different length. Because B, all of its sides are marked with just that 1 line, that's telling us that all the sides are the equal length. And the same thing with the angles on the inside. All of those angles are marked, or the interior angles are kind of marked with that little moon shape or that connecting half circle. That's telling us also that all of the interior angles are congruent. Over here, we might have one that looks like this, and then one that looks like this, and one looks like this, and then one looks like this with 4. That's telling us all of the angles are different. And that might not be necessarily true. I'm just giving you an example of what the angles would look like if they were all different. So this one is, it's a 6-sided polygon with all the sides are the same length and all angles are equal in measure. So we can say that this shape, which we would identify, actually I forgot to put over here, ABCD is a quadrilateral. This one we would say E, F, G, H, I, J is a regular hexagon. Over here, you can also say this is a four-sided polygon. We're going to learn lots of new words today. You may or may not be familiar with them. All right. So being able to identify and name the shapes, that's an important skill. Or that's like an important, objective you want to get out of this chapter or this section of the chapter. Okay, so now let's talk specifically about triangles. So there are different types of triangles. We can classify the triangles by their sides and also by their angles. If the triangle has 3 equal sides, we call that an equilateral triangle. That's also going to be our regular polygon. If the triangle has 2 equal sides, we call that an isosceles triangle. And if it has no equal sides, that's a scalene triangle. You probably, unless you've seen this before and you've done it before and you've memorized it before, you probably won't have this, like, you're not going to be able to review this and memorize all of this. So as you're going through this chapter and the homework and everything, make sure you have these notes handy so that you can reference and you can check and you can look up the name of each triangle or the name of each shape or the characteristics of each shape. By angle, a triangle is an acute triangle if it has 3 angles that are less than 90 degrees. So all 3 are less than 90. A triangle is a right triangle if it has 1 angle that equals 90 degrees. So here we can see that's 90. And a triangle is an obtuse triangle if it has 1 angle that's greater than 90 degrees. So we can say that. We can see that's right here. That's our obtuse angle. Okay. And be aware or take note of how when it says if it's an acute triangle, all 3 angles have to be less than 90. Because if you look at the obtuse, this is going to be an acute angle, and this is going to be an acute angle because these two are less than 90 degrees, but we also have an obtuse. So this one would not be an acute triangle because all 3 are not acute. Okay, so let's do an example. Classify these triangles, triangle ABC, triangle DEF, and triangle GHI according to their measures of their angles and the lengths of their sides. So you can go ahead and pause here. I'm going to zoom out a little bit so we can see everything on one page. Pause here and see if you can name these triangles based on the notes above, and then come back for the answer. All right, triangle ABC. So when we look at triangle ABC, we can see that the sides are all different lengths because this first side is marked with one little tick mark, 1 dash. This one has 2 dashes and this one has 3 dashes. So that tells us that they're all 3 different sides. So they're not equal. So this is going to be a scalene triangle because it has no equal sides. And we can also see that it has 1 obtuse angle, which is right. So if it was right triangle, it would be straight up and down. That would be 90 degrees. But that line, the line AB, it goes a little bit past that 90 degrees. So we would actually call this an obtuse scalene triangle. Okay, let's look at DEF. DEF, so whenever we classify triangles, we do the angle first and then the side, or we kind of say what it is by the angle, acute, right, or obtuse, and then we say equilateral, isosceles, or scalene. So this one has 2 sides that are the same because we can see that this side has 1 line, this side has 1 line. That tells us those are equal. We can also see that it has a right angle because it has this little box or square in the corner. So because it has at least 1 right angle, we're going to say it's a right triangle. And because it has 2 sides that are equal, it's a right isosceles. Isosceles. It's a hard word to spell. Right isosceles triangle. All right, and last but not least, we have GHI. So we know that GHI has three sides that are equal because we have the three. Each side is marked with just one. So we know that's going to be an equilateral triangle. And all of the all of the angles inside the triangle are acute. So that is an acute equilateral triangle. So I guess maybe you want to put the number 1 here and the number 2 here. In a perfect world, I guess I should have flipped those. But that's kind of just the way that I inserted it into the document. But you want to look at the angles first, and that's how we're going to, when we classify the triangle. So angle then side, obtuse, scalene, right, isosceles, acute, equilateral. All right, so moving on. Actually, did I take a screenshot? I think so. Okay. Let's move on to the triangle sum theorem. The triangle sum theorem, there's a whole bunch of words over here, right? Basically, what you have to remember is that if you add up the interior angles, the three interior angles of a triangle, it will always equal 180 degrees. So the triangle, I'll read it. Triangle sum theorem states that the sum of three interior angles of a triangle add up to 180 degrees. In this triangle ABC, we have angles A, angles B, and angle C are all three angles of triangle ABC. So therefore, the angle of A plus the angle of B plus the angle measurement of C equals 180 degrees. So we can use this, and the reason why this is important to remember is we can use it to find unknown angles. For example, in this example, it's asking us to write and solve an equation to find the measurement of angle X right here. So X is usually our variable, but in this case, it's an angle. It's the vertex of this triangle. So, but you can also use it as a variable. So we know that the measurement of angle X plus the measurement of angle Y plus the measurement of angle Z must equal 180 degrees because that's the triangle sum theorem. We don't know what the angle of X is, but we know that the measurement of angle Y is 116, and we know that the measurement of Z is 22. And that is equal to 80. So now we just combine like terms. We're going to add 116 and 22. So the angle of X plus 138 equals 180. And then subtract 138 from both sides. We get the measurement of angle X equals 42 degrees. And you can always double check that number by going back and adding 42, 116, and 22. You can go back and add those together and make sure they equal 180. If they do, perfect. And if they don't, then you have to go back and recalculate. Okay. So using that triangle sum theorem to find missing angles. And last but not least, so we talked about triangles, our three-sided polygons. Now let's talk about quadrilaterals. A quadrilateral is a polygon that has exactly 4 sides, and the sum of the interior angles is always 360 degrees. So remember the triangles, the sum of the interior angles equals 180. With quadrilaterals, the interior angles always equal 360 degrees. There are different types. This one has 6 types, actually. This one, oh no, it doesn't, because quadrilaterals at the top. There are 5 kind of special types of quadrilaterals that have their own specific and definition, their own kind of characteristics. So at the top, we have quadrilateral. The properties are that it has 4 sides. The trapezoid, which you probably have heard about before, we learned kind of when you're in the early elementary grades, you learn about what a trapezoid looks like. The definition, or like the mathematical definition or the qualification to become a trapezoid, is having 4 sides because it's quadrilateral, and it has to have one set of parallel lines. So you can see, and I apologize, this one's a little bit fuzzy, this picture, but you can see the top and the bottom of the trapezoid have these little arrow marks. That tells us that they're parallel. And parallel meaning they can run on and on forever and never touch, right? If we extended these on like this and like this, they would never touch. Two parallel roads, you can have two people, you can have, you can be driving on the first road and your cousin can be driving on the second road. And if they're parallel, you're never going to see each other. You're never going to cross. The roads are never going to intersect. Okay, parallelogram. That one has 4 sides because it's a quadrilateral. The qualifications or the characteristics of the parallelogram, it has to have 2 sets of parallel sides. So kind of similar to what we were seeing when they were kind of showing us how we show that the triangle sides are equal. They had like those like this. The same thing with parallel. So if you see that little like arrow, it's telling us that this side and this side are parallel, this side and this side are parallel because it has 2, okay? So 2 sets of parallel lines. A rhombus has 4 equal sides, so a little bit different. The sides all have to be equal length, and it has to have 2 sets of parallel sides. And this one's set up so you can see the 4 lines, meaning that the 4 sides are equal, okay? A rectangle, we have rectangle and square. Rectangle has 4 sides with 4 right angles. That is the characteristics, qualifications to become a rectangle. A square is very similar, but it has to have equal sides. So 4 equal sides, 4 right angles. So you've probably heard before that a square is a rectangle, but a rectangle can never be a square. Similar to that, because if you think about it, the square, it does have 4 sides and it does have 4 right angles. So a square is a square can also be a rectangle, but a rectangle can never be a square. However, if you see this, right, if you see a shape with 4 equal sides and 4 right angles, you should always label it as a square. Never say that it's a rectangle, because yes, it is a rectangle, but more specifically, it's a square. Okay, it's like saying like 3 is a real number instead of saying like 3 is a whole number or 3 is a counting number, something like that. You want to be as specific as possible. Okay, so write and solve an equation to find the angle of the measurement of angle A. This is similar to the triangles that we were doing because we know if we look up above the qualifications to become a quadrilateral, it tells us the sum of the interior angles is always 360 degrees. So we know if we add up these 4 angles, we should get 360. So the measurement of A plus the measurement of B plus the measurement of C plus the measurement of D equals 360. We don't know the measurement of A, that's what we're trying to find, but we know B is 80, we know C is 55, we know D is 120, and that should all equal 360. So we're going to add these numbers up together. If we add 80 and 120, we get 200, then 255. Yep, that's right. And the angle of A plus 255 equals 360. And so just think of this as a variable that we're trying to solve for. So we're going to use the inverse operations, just like normal, to find the measurement of angle A equals 105 degrees. This is 105 degrees. Make sure you always put that degree mark after, because it is that's the unit that we measure it in. And again, if you want to check, you can pause and check here if you would like to. Go back in and add up. Add 80 plus 105 plus 120 plus 55 and make sure we get 360. And I think that is the very last one. It is. Okay, so for the homework, let me take a screenshot of this and move over to the homework. The first page is identifying the type of each quadrilateral. be as specific as you can. So like we talked about, if it's a square, call it a square. Don't call it a rectangle, even though it technically is also a rectangle. Be specific. Pay attention to the different lines and the arrows and if there's a right angle or not. These will all be within your notes. The notes will help you to solve this. Then for the second page, find the measure of the missing angle. All of these are going to be quadrilaterals. All of these are quadrilaterals. And all quadrilaterals, the interior angles have to equal 360 degrees. So for this one, you're going to solve this one the same way that we solved the very last problem down here. All right, so thank you for sticking with me for 27 minutes. If you guys have any trouble or if you need any help, always feel free to send me a message and I will see you next time.